So this is the first class of advanced Python programming, we can say. This is Python programming class 26. If you remember, we ended with 15. Another 6 classes will be object-oriented programming. And then we'll have some videos, extra 4 videos for other stuff. There are some problems we'll solve. The fundamental package on this, we have others like pandas, matplotlib, everything is based. It will take some time, maybe 3 to 4 classes it will take. Will not be in a hurry. Let's do it properly, whatever we will do. Because if you learn NumPy properly, ML stuff will come later, then deep learning, artificial intelligence, but everywhere you have to use NumPy. So these 2 lines you need to remember. This time, after each class, I will send you these files so that it will be easier for you. You can see the code and then you can try to get things done on your system as well. Otherwise, what will happen? It will be difficult. Last time I sent videos, so many students requested me to send these files as well. Yeah, this time I will send you after each class. So this is the fundamental array processing package for scientific computing. And we talk about n-dimensional array here. So just for a visualization, so that you can think this way, you can imagine this way. Yeah, you can. This is 1D array. This is 2D array. This is 3D array. So to understand this, I'll take you to one picture, and how to save a picture you have to know. Then you will be able to understand the meaning of frames here. See, when we talk about 1D array, here this is one dimensional, and 1, 2, 3. 3 numbers are written, but this is 1D. You have 2D, one frame here. This is 3 cross 3 though. This is 2D. ND, we are talking about n-dimensional array. Though this will be saved in a different way, in row only. That's a separate thing. But yeah, it's ultimately it's 2D, it's 1D, and it's 3D. 3D means 3 frames are here. This is 3D. What will happen is, you will have 3 frames. The first one will say the number of frames here, and then 3 cross 3. This is 3 cross 3. You can see 1, 1, 1, 1, 2, 3. So 3 rows and 3 columns. That way 3 cross 3, and that type 3 frames are there. Now what we can do using NumPy? Before going to NumPy, what we can do using NumPy? Before that, I'll take you here. Suppose I want to wish you, I want to greet you. See, I'm writing here. Welcome to advanced, or maybe let me write NumPy. See, to say this, I have to utter these numbers 0, 1, 0, 1, all that. This is equivalent to this. So if you check here, randomly I got this. There are so many text to binary. Text to binary. Whatever text you write, everything will be converted to binary. Okay. So whatever you write, everything will be converted to binary. So this is not a new one. We have ASCII, ASCII conversion. Okay. So for every number, for small case letters, for capital letters, if you write H here, we have a number. If you write small h, and then you write comma, then you write I, you write a number 8. So for every every letter or comma, whatever you write, our human language, whatever you want to write, you will have a corresponding binary transformation. So this is not new. You can transfer everything to zeros and ones so that computer can understand. That's the main thing here. Suppose I'm writing this way, text, you have a binary one. That's fine. So you can say this is a code for this. This one, if you want to decode this one, you will get this message. Okay. Now, here in NumPy, you see, Asta is one of my student, and while teaching R programming long back, she gave me permission to use her profile. Even she is now working in Bangalore only. So what I did is I saved this image using this NumPy. It will take 3 classes for you to code your image. Suppose you want to write a code, that code, these numbers is printing this one. Okay. So what I did is here, I'll show you what I did here. See, these things are, I mean, for printing, we are using, I mean, I am so matplotlib, this is a name and all that. You need not to worry. So we'll do matplotlib later. Let's not worry because I wanted to print that one. So we are, for visualization, we use matplotlib.pyplot. And here print all these things. They are print statements only. What we are doing is we are trying to print this one. Asta I've kept here in desktop. So I wanted to bring here. So these two lines you need to remember. Even I will show you. This is just a visualization so that you will be able to know. You will study 1D array, 2D array, and 3D array. 3 frames here. Here 1 frame. Here also one, you can say, line. Now to get this image, you have to write these 2 lines. I'll send you this file. So IPython, because Jupyter was IPython before, that's why the same name. Display import image, you have to write this line. Then image, here you have to write the path. Okay. Suppose where I've kept in documents. Suppose there is a file in documents or whatever, wherever you want. Suppose I'll take it here. Suppose this one I want to I want to import. So you go to this one, the path is given. Okay. You bring the path this way, you copy this, whatever image you want to take. Then you paste it here. And then remember to change this one to this, because the way we use in Windows, that will not work here. We use forward slash. That is one way. If you don't like that, so you can do this way also, double, whatever it's good for you. This is the path. And then you write the name, whatever name you have, numpy, whatever you have, dot png. If it's a png file, dot png. If it's a jpg file, write dot jpg. Then you just write this much, right? Copy. This is the second line. And these 2 lines are fixed. If you want to import any image, normally what happens is whenever you are doing a mini project, you need to show first what you want to do, something, one picture, so that you will have an idea what you want to do here. So for that you need to import any kind of image. To get the image here, you have to write these two lines. The only thing you need to see here is the path, wherever you kept the path, this is the path, and then the name, whatever name you have given. And if it's documents, you write documents. If it's desktop, you write desktop, or downloads, whatever you have, you write that here, and then you just run this one, you will get this. That's all, two lines. This you must be knowing. You make it in the markdown mode, whatever you write. If you give space, then you can take this way, then run it, you will get this one. This will be a heading. And here, this one also, if you check, see, one hash sign is here. Then here, if you check, two here. So little bit smaller it will be. You see the size here, see the size here. Okay, this is also important. Now, for any image, if you want to take this way, you can do. Now this image, I wanted to code this image. I wanted to code this using NumPy. So this is a NumPy code. Now suppose I will take another. Let me run this. This is also code. If you decode, you will get the image. See this one. This is blur because the resolution is different. But anyway, you got an image. So can you imagine how you can keep this image in numbers using numbers? These are numbers, right? That is a part of image processing. We'll do in the third week of this month, or maybe towards the end of this month. Okay, what is image processing? You have to know first of all how you can keep this image in numbers. But remember how powerful it is. It's able to store one image using numbers. Not only image, a video, small video I can show you, but yeah, I'm not going to that now. So how you get a video? Video means you have frames. Suppose like this, I have 100 frames. So if you collect all those 100 frames and how fast you want to run, you decide, then you have a video. So video means, I say, suppose I have a 5-second video, maybe I have 100 images. So those 100 images are the 100 frames here, this way. These are the frames, 1, 2, 3, 4, that way. So what we can do using NumPy, that is what we'll be learning in the next 3 classes, today, tomorrow, day after tomorrow, and maybe prequel one more class. Will not worry, because this is very, very important, fundamental and important. Once you do it, once this is over, then I'll tell you what you can't do using NumPy. Then we'll move on and we'll go to the next package, that is pandas. NumPy, pandas, matplotlib. If you do these three properly, then everything will fall in place one by one. We'll go to ML. Of course, you will be needing CS1 here. The concept of CS1 will be required. What is a normal distribution? What is a binomial distribution? What is hypothesis test? What is regression? I don't want to do the problems of actuarial science, but yeah, that is applied statistics, so you'll be needing that. Now, let's get started here. How to create one simple array. Suppose I write import numpy. I can write this way, and this is compulsory. By chance, if you forget to write, you will not be able to do anything. Let me write a is equal to numpy dot array. This is the notation, remember. And here you write any list. Suppose 10, 20, 30. This is a list, one list. Then I can write another. NumPy is 5 letter. If you want, you can make it NumPy as NP. This is better. That way, what will happen? Every time you will be able to write it using NP. So this is the syntax you need to remember. Import NumPy as NP. A I have created, B I have created. These are the two. Suppose 1, 2, 3. Yeah, it's fine. Working. Now I can print. If you want to see how A looks and B looks, just run it. 10, 20, 30, 1, 2, 3. In case you are wondering to compare these list type of things, I can say this is a list, another thing. But if you write print type, I'll tell you something. See, this is NumPy 1D array. For everything we write ND, N is 1 here. So the class of A. If you want, you can check the class of B also. But you know what class this is. Now let's go back to list for a while. Suppose C is a list. The same thing I'm taking here. 10, 20, 30. See the difference? Here we have to write this way. Here you have to write this. This is a list. You can name this also. Even if I define it C, you can use this C. 10, 20, 30. If I write here, 10, 20, 30. If I write here, this name also, after running this one, I can write here. Remember to write np dot. If you are wondering and you never did object-oriented programming in Python, just remember it. You will learn more why we are writing dot, but make it sure to write dot. Even without doing object-oriented programming, successfully you will be able to study this. It will not create any problem. The only thing is, whatever name you have given, you can give n also, n dot array. If you don't want to write np, then also it's fine. But we will not do that way. For everything we have to import. You have to write from NumPy, import np, you know those things already in Python. But yeah, it's better. And everywhere, not only one document, if you see 1,000 documents, because everywhere they've used already in NumPy since last 5-6 years. So you will get np only. Some they write np, num, some write NumPy. That's very, I mean, small. It's only 1% population they use. But this is a very, very common notation. np.array. Remember, all the time you have to write np.array, and you just write a list here. Later, when you are practicing, you can write a tuple. You can check what you are getting. If you write some other thing, what you are getting, what is the type, all those things you can know later. But simply to start with, you write list here, write a list here, and check what output you are getting. It looks like a list, but ultimately it's a NumPy array. What you can't do here using list and what you can do here, that I want to discuss before proceeding further. So let me change it to 11, 21, 31, and then D 1, 2, 3. Now I want to add, okay, I want to add C and D. Print I can write, or I can give another variable. Directly I can write print C plus D. I want to know what is C plus D. Obviously, I would like this to be 1, 2, 2, 2, and 3, 2. Unfortunately, I got this way. This is just a concatenation. What happened is, whatever list I had here and another here, both I got. But this is not I wanted. This is not what I wanted. I wanted the sum of first element with the first element, second element with the second element, third one with the third one. Unfortunately, I didn't get, because in list you don't get that way. So how can you do mathematical operations in list? It's not possible. You can write a program, that's a separate thing. You can write this way. You can add one by one. Suppose you create another list. Yeah, the members you write 0, 0, 0, 3, 0. Then you update. E0 you can write, or you write a for loop. Anything you write, it doesn't matter. Ultimately, because we'll change, E0 is C0 plus D0, right? We can write that way. So all these things you have to do. If there are many, you have to write a for loop. So if you element by element, if you update, if you run this one, then if you print D, one element is already updated, right? So print E, sorry. See, 1 we got already, 11 plus 1, 12, line 3. So already we got this, see, 11 plus 1, 12. If you write another line, you will get this, 21 plus 2, 23. So you have to add this way. So element by element, if you add, and you write random one here, then change these by the assignment statements, and ultimately things will be changed to whatever you wanted to add, right? Yeah, that way you will get. There are 3 elements, it's fine. If you have 100 elements here, 100 elements here, you write a for loop. That way you can add, but you can add directly. Then if you want to multiply C with 5, suppose I wanted to multiply C by 5, then see, 5 times I got the same thing. Once, twice, thrice, 4 times, 5 times. But I wanted 11 into 5, 55, 21 into 5, 121, 31 into 5, 155. But I didn't get. That's the problem with list. Even we'll do linear algebra using NumPy, but lists we can do. We can import one Excel file. Of course, we don't do that here. That's a concept of data frame that will come next in pandas. But yeah, we can take those, but whole lot of things you will be able to do in pandas. Something we don't do in NumPy, but we'll go to that later. First, what we can do using NumPy, we'll target there. Once this is over, then we'll try to know what we can do in NumPy. Then we'll go to pandas. Now, see, I've created. You remember, mostly in 70% of the cases, you have to write array. There are other ways as well, zeros, ones, and all that. We'll go to that later. But yeah, you start writing array this way. So if you want, you can check type of a. We already checked here. Now let's multiply by 5. Then print a plus b. You can print a first, because here it looks this way. It's a bit messy. Once you created, don't see all this. If you are new to this, just print it. It looks neat. 10, 20, 30. These are the three elements here. And 1, 2, 3. So if you want to add A and B, A plus B, you get 11, 22, 33. We multiplied this by 5. So each element is multiplied by 5. Okay. Not only that, you can subtract, you can divide. I can write this also. A divided by B. I can write A divided by 5. A divided by B means what? A divided by means all elements will be divided, element by element. Okay. If you run, you get it. Now, here it's homogeneous. Unlike lists, in list I can write this. Suppose it's a normal list. Again, let me write C. I can write here Amit. I can write here number. I can write a float here, float point 0.6, and whatever we want, we can write. This is a tuple. This is a list. Run it. It's working. But here it's heterogeneous. This is homogeneous. You can't write this way. It's not allowed. This way we can't write. If I try to replace, this is a list. So I copy this one and I write here. And let's run it. You write print A. See, I got all this. But if you check type, you will be able to know print type of A. This is numpy nd array. Numpy nd array. That's fine. So individually will check A not. Then A1. Then A2. Then A3. How many are there? 1, 2, 3, 4. Before printing, I'm checking the types. So it gave me string, integer, float, and tuple. These are the types. So now what happened is dot shape. If you write a dot shape here, here we have 4, and then we don't have any other. Suppose B np dot array 10, 20. Then you write a comma here, 30, 40. So now run this one. There is an error here. What is that error? Who can answer? What is the error here? Anyone?
Sir, a list can contain different data types, but we cannot really add multiple list types, so it shows type error.
Data time not understood, right? So how can we modify this?
Um,
See, what happened
So
is
we
here,
can try
here,
concatenating two lists, like
no, no, no,
adding
no.
into a list.
See, ultimately, you have to keep within a list. What happened is this total is considered as one. Now, if you write it here this way, suppose I write this, then this will be accepted. Now,
Yes.
if you print B here, if you print B here, this is a 2 cross 2. You check it, print B dot shape. Now it's a 2 cross 2. 2 cross 2, how can you know? You have, suppose you have two rows and two columns. Suppose I will make it 45 and then 65. Then if you run it, this is 2 cross 3. So 2 means, remember, two rows and three columns. 1, 2, 3. 1, 2, 3. Three columns and two rows. It will come this way. Now suppose I want to make it a 3D array. Suppose I want to make it a 3D array. Can I write this? Remember, you have to write three brackets. Then you try to run it. Okay, let me write C here. And you run it. I can write this, copy. You tell me the shape here. Do you agree 2 cross 3? Why I've written 3 here.
So we have printed B again. I think we have to print C.
Okay, let me change. Yeah, this is 1, 2, 3. What is the meaning of that? One means, remember, you have one frame, that is 2 cross 3. So then what is the difference between this and this? Here this is 2 cross 3. Here this is 1, 2 cross 3. There is a still there is a difference. I've written 3 here. What I will do is, suppose I will add one more here. See, this is 1. This is 1. Okay. So suppose I will add one more here. Now tell me what will be the shape? 1, 3, 3 again. Why 1 is not going? 1, 3, 3 means, let me write. If you want, I can write all these. Wait for a minute. We have 10, 20, 45. Here it's written this way, 10, 20, 45. It's already there. Okay. There is one frame. It's already there. I need not write this one only. This is one frame here. But how I can get two frames? Two frames means it will be like this. One frame. Then I have another frame. I want that way. And then another frame. So here I want elements. Here I want elements. Here I want elements, that way. Here there is only one frame. Though it's a 3D array, if you check the type, it will show n will be 3. But yeah, the structure is of a 3D array. It's not 2D. Though it's showing one frame only. We can make it. How can you make it 2? Okay, let me erase this one. Now see, how can you know? You cut this one. You cut this one. Now at least this is 2 cross 3. Already it's here. This and this, B and C, they are same. Total, oh, I've added one. Okay, let me cut that one as well. So now exactly they are the same. Even if you want, I can copy this. The whole I copied, okay? There is no confusion now. And I deleted. Then I will write one bracket. Then here I will paste, okay? Once I pasted, comma, twice I pasted. So what happened is this is what I copied and pasted here. This is what I pasted. Twice I pasted, okay? The triple bracket, the last bracket, let it be there. Then what will happen? Here the same thing I copied. That means you have two copies. Okay. You need another bracket for that. So I've written another bracket. If you want, you can change the elements. No problem. Now run it. See here, this is two copies of 2 into 3. Two copies of 2 into 3. The copies are also shown here. One copy, two copy. They are not same though. I change the elements. And then this is 2 cross 3 means here 2 rows, 3 columns. Here 2 rows, 3 columns. Now go back to the image. You see the shape here. 3 are there. That means how many frames are there? For this one, 183 frames are there. Okay. Then 276 cross 3. So how many rows we have? We have 273 rows and 3 columns. Why 3 columns? There is a reason. I'll go to that. Again, you see so many 255 here. So don't think that everything is written. Dot, dot, dot is here. You have to get 183 frames of 276 rows and 3 columns. There you keep the image. So collection of frames, why you collect frames and all that, everything will be able to know. We'll discuss that in image processing, because this is where we save the image. How to process the image? What is processing? Suppose I want to make it larger, or maybe I want to make this portion relevant, and this person I want to keep it light. I want to change the color. I can make it black and white. Everything we can do. There are so many ways. One way is using OpenCV, but yeah, there are various ways. But I'm not going to that now. Even in NumPy also we can do, but it's a little bit difficult. I showed you how to save one image, the code. Now, if you go back here, remember there are 2 frames. You can draw 2 frames. See, I showed here how many frames? 3 frames here. 1, 2, 3. This is 3D array. This is 2D array. This is 1D array. You can write names as well. Amit, Ramit, Rachit, whatever you want. Here you can write names. You can write decimal numbers. So coming back to this, see here, I have 2 frames. Okay. If you want to make 3 frames here, remember you have to copy this one, copy, and here Control B, I pasted. Sorry. You run it now. We got 3 frames here, and all the frames are 2 cross 3. Remember, this becomes I now, the number of frames. Then the dimension, 2 rows and 3 columns. Okay, 2 rows, this way you can count, and 3 columns. 2 rows, 3 columns. Here 2 rows, 3 columns. Now, I go back, Control Z. So now I have 2 frames. Okay. Now suppose I have one here and then I pasted this one. Now what I want is, I want to make it 2 cross 3 I had. I want to make it 2, 2 cross 2 cross 2. How it's possible? I want 2 frames or 3 frames. That will depend on what you write here. Again, if you see this there is one here, there are two here. It might be a little bit confusing initially. You have to practice, but yeah, you'll be able to know. The main thing you need to see is, if you have three brackets, you cut this bracket first of all. You cut this bracket. Okay. You transfer to 2 cross 2. Then out of 2 cross 2, this will be your 1. There is one bracket here because this is 1. Okay. This is one 2D array. This is one 2D array. So from 2D array, you make copies, you will get 3D array. That is the way you need to remember. Suppose I write the same, okay. Let me, three brackets here, and then I make it also 1. Then what will happen? Suppose I cut this one. Then what will happen? Will it work first of all? These are the things you need to try, play with this. 1, 4, 3. 1, 4, 3 I got. First of all, you cut this, you cut this. Now, if you start from here, double bracket ended here. That means what? Within triple bracket, we have only one. Double bracket didn't end here, it ended here. That means this total is 1, only one frame. Only one frame, one frame. In that frame, how many rows are there? It's written, you see, 10, 20, 45, 30, 40, 65 here. And then this one, then this one, then this one. Okay, this way. So if you want to have more copies, you can do that way. That will come here. Then number of rows, number of columns here. Now, let me check what is there in NumPy. If you want to master, it might take a month's time. Remember. But yeah, when you practice a lot, you do a lot of stuff, then you, that way you can remember. See, whole lot of things are here. So what we use regularly, we'll concentrate there. Okay, lot of things are here, so I'm not going to that. We'll start with range. Okay, suppose, but np dot you have to write anyway. You have seen this one, range, range, range function. Suppose you write 10 here, that means 0 to 9. Range function is there in base Python, but here in NumPy, because everything you do here starting from now, you have to use NumPy, pandas, all this. Will not go back to base Python, because base Python is not required. Why NumPy? There is a reason. Why not list? At least I showed you one reason. Other reasons are there. It's very fast. NumPy is faster than the list and all that. You need to write a lot of for loops and other stuff. It's not required here. So here the notation is arrange, and you need to write NumPy, that is NP. We've already decided that we'll take NP for NumPy. So you can write np.arrange10. If you run this one, or you write a here print, or directly you print this, then you get 0, 1 up to 9. If you want to print range function, you can write the starting point also, and then another one you can write. Or if you want to start from 0, you can write this way, 0 to 9. Here also you will get, but you won't get, right? There is a reason, 0 to 10. But if you want to get this way, you have to make a list. If you write a list, you get it. But anyway, we'll not go to that. Yeah, I joined, others were requesting. Yeah, we will not go to that. So remember now, a range, it's not range, a range you have to use, and every whatever you do, you have to use .np. So we'll not think about that once more. If you write this way, 10 to 5, and np it will take 1. Suppose we have doubt, how can you check? You write help, you copy this. See, there is a start here, there is a stop here. D type. D type will go to that data type later, but yeah, start stop is there. So what we wrote then, if you remember, I wrote 5 instead of 15. So what happened? I didn't get anything. Instead, if you write a 15 here, because you're starting, it's same as range, it's no different. The only thing is we write a range here, and you have to write np dots. So now you will be able to generate a lot of
Uh,
numbers.
so if you write given a negative value, will it go in reverse?
Yeah, yeah, no
Right.
problem. Yeah. I mean, I didn't get you exactly.
So if it is like
You have
10
to
comma
write here
minus
now.
5,
Here you have to write the gap. Suppose 10 to 15 minus 1 you will write. Then it will not work. 10 to 15 you don't write. Suppose I will write 2 here. Will it work in range first of all? See, 10 to 12, right? But if I write 5 here, you are saying this minus 1. You are saying this.
so I was saying 10 comma minus 5.
You want this? No, let me cut this one. This. No, how can you go from 10 to minus 5? That is the thing. But you can
Right.
go, remember that one, control Z you write, 10 to minus 5 you have written, but the step is minus 5. You are going down. If you don't write, automatically it will take plus 1. This way you won't get, okay?
All right.
So let me cut this. Yeah, 2 brackets I need. For print, I need another bracket. This way. This way means the starting will be 0. It's not given. You write another one means this will be the starting. You have to go to that. If you want only even numbers, then you write 2 here. But you won't get 20. The starting is 10. So for that you have to write 21 or 22. If you write 21, up to 21, it will give you with a 2 gap, 10, 12, 14, 16, 18, 20, that way. So this is the a range function. It's exactly like the range function, whatever way that works, it works the same way. We need not worry a lot about that. Then another one frequently we'll use, and I want to go to that, the random module. If you want, you can check random module, but I'm writing here. You run this. So np.random.rand. So I got one number between 0 and 1. Uniform number. When I talk about uniform numbers, this is from a uniform distribution. So let me write here. We have U01 distribution, uniform 0, 1 here. Because we are not talking about only integers, we have infinite number of numbers. Suppose from 0 to 1, you want to get a number randomly. The random number we got is it's little bit right to the middle number. Middle number is 0.5. This number we got. Now, yeah. Now suppose I copy it. There is a random module. Suppose I write here random. We had random dot random. Here we write rand. Random module was there, but it will not work here. Why it didn't work? Oh, it worked here. Yeah, it worked because I did that. Okay. Import random you have to write. Otherwise it will not work. If you want to check, open a new one. I must have used here. See, it's not working, right? Because random is not defined, it says. This is not there, this is there in random module. So you have to write import random. There it worked because I imported before. Maybe random, import random. I must have imported whenever I worked, it was open since morning 9, whatever I worked, I must have used random there. Okay. And the same thing I updated and I've kept for you when I started my class. That's how you got it. This is a random number between 0 to 1. Where is our original one? Okay, it's here. So this is random dot random. I got 1. No, it's there. Yeah. Yeah, this one. Now let me copy. No, this is not required, right? Now I've written twice here. You run it. Why I'm getting only once? Who can answer? Twice I've written. I should have got 2, right? If you write print, you will get 2. If you don't write a print statement, it takes only once. If you write a print here, then you get 2. Otherwise, you name it, you store it. You write print A, then print once again. So here also you got 0.899.2 numbers we got. Suppose you want to get 100 numbers between 0 and 1. How can you get 100 numbers between 0 and 1? You have to write a for loop. For I, this for loop is from base Python. For I in range, let's write 10 first. This one. You run it. Okay, print statement I have to write. So what is the work of np.random.rand? If you write I here, I will be printed. But if I write 5 here, 10 times 5 will, this is a constant, all the times 5. But how many times you write 5 times here? 5 times 5 is printed. Whatever you write, that will be printed. Suppose I want to write star, star will be printed. So what I'm saying is, for I in range 5, I will be 0, then you print star, then for I1 you print star. If I write a I here, I dependency will come, I every time. But again, I is within quotes. You have to remove I. So this becomes variable. Now you get 0, 1 to 4. So instead of I can write I square, I power 3, all that we know already from base Python. Now this one. So wherever you write this one and enter, you get a uniform number between 0 to 1. Any number between 0 to 1 randomly. So because we print 5 times, so 5 random numbers we will get here. And if you want to find the mean, if this is unbiased, those who are from statistics background, for them, unbiased has a meaning. Unbiased means what? We have two numbers 0 and 1. Zero point 0.5 is the middle one. Before 0.5, you should have half of the numbers, and after 0.5. For that, I'll write it 6. So 3 should be less than 0.5. 3 should be more than 0.5. This is 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 more than 0.5. Oh, this is more than zero point 0.5. This is less than zero point 0.5. If you find the sample mean, population mean is zero point 0.5. Population means the ideal is zero point 0.5. Ideally, when you take 6 numbers from U01 and you take the average, before taking the average, ideally it should be zero point 0.5. But here you will not get zero point 0.5. You will get a very big number because this is a unbiased sample. It's not, this is a biased sample. This is not unbiased because you have many numbers more than zero point 0.5, very less number of numbers, that is only one which is less than zero point 0.5. That is the problem. You can try with 10 also, because random, if you run once again, you will get different numbers. So now you see this is less than zero point 0.5, this is less than zero point 0.5, this is less than zero point 0.5. This is fine. This is a better sample than that, because three numbers are more than zero point 0.5, three numbers are less than zero point 0.5. So we expect that if we take the mean, we'll get a number around zero point 0.5 without finding. You can try. Okay. Can you find the mean? For that, you have to save these numbers. Okay. Where you will save these numbers? AI, AI. So, but you should have A first of all. AI. If it's not, if you have not constructed a list before, then that will be a problem. So you write any 0, 1, whatever you want to write. How many? 1, 2, 3, 4, 5, 6. If there are many, there is a way you can multiply 6 in base Python list. Just write this way also 6. That's fine. But yeah, let it be like this so that you'll understand. So every time this loop will work for I in range starting from 0. Say, suppose I0, A0 will be assigned to this random number. This you get randomly. Okay. Now, I'm not printing anything. Okay. Let's skip. Yeah, it's working. Print A here. Print A here as well. See, here we had 0, 0, 0. But after for loop, we updated this by these random ones. So now let's cut this only to show you. Now it's clean. 1, 2, 3, 4, 5, 6. So if you want to find the mean of 6 numbers, Nibita, how can you find the mean of 6 numbers?
So import statistics and we use
Mm,
mean.
okay, you're doing very nice. So when you started? 3 days.
3 days before, sir.
Okay, good. Input statistics, then find the mean of statistics. dot mean, right? Statistics dot mean. You write a here. That way, directly you can find mean of a, because mean is not a built-in function of Python. So it's there in this module statistics. So run it now. Mean of a we wanted. So we'll not print this. We print. Okay. I've written twice. Now mean of a, statistics dot mean of a, this is 1, print 1. So I got 0.47 here. We have central limit here. More numbers if you find, suppose instead of 6, why I'm not printing a, because it will take a lot of space. I will not print. I will find only mean. 60 numbers you take. Okay, it's better. Let me write this way. 60, right? Multiply by 60. Now see, it's very close to 0.5. What is the mean of uniform distribution? Anyone? What is the ideal mean of uniform distribution? If you randomly, if you take 10 numbers from U01, I mean, you just think numbers between 0 to 1. Someone will think 0.4. For that, someone else will think zero point 0.6. The mean is zero point 0.5. So that's what we expect. See, it's so close to 0 0.5. The more the numbers, this is a kind of simulation. Okay, we have to increase this one as well. Because here we have 60 spaces, but we want to keep 600 here. We are updating 600 here. You can make it less, others will be 0, but you can't make that less, right? Yeah, run it. You got 0.49. It's around, it's not that more the number, the better will be the answer. This kind of a sampling is there in statistics as well. If n tends to infinity, then when the sample gets better, there is a name. I'm leaving it for you. Okay, it's homework for you. That is there in CS1 only. When the numbers are tending to infinity, the number tending to infinity, when you have large number of numbers, in some cases it will approach towards mean. Mean is 0.5 here. In some cases it will not. You identify. Now you make it 6,000. See, it's much closer. So yeah, the 6,000 numbers, if you want to see, you can see all these numbers. So today's class is over. I want to leave you here. We'll continue tomorrow, same time. But before going, I just want to say you something important. Uh, okay, you practice. We'll do next time. I'll send you this file as well. But I'm changing here, so the video will be more helpful. But yeah, initially, if you want to write, you can use this one. Okay, I'll mail you the video. Class is over now. Thank you. See you next time.
Thank you, sir.
Okay.